This is an extension of solving for similar figures. And I wanted to do these two as an example because you notice this one's slightly different because we have triangles within triangles. Okay. So anytime you see something like this, okay, we're still going to follow all the same rules that we use to solve for the missing side of a figure in our other video on how to solve for the missing side of a similar figure. But this one is slightly different because obviously it looks different. Okay, the easiest thing you can do is make it look like your other problem. So how do we do that? Well, we're going to do that by actually separating the triangles. Okay, so you notice I have a small triangle here, which is listed GKH. And then I have a larger triangle, JKL. Okay, so to make it easier, separate them. Redraw them. They don't have to be perfect, needless to say, because I can't draw. So here's JKL. And then I have my small triangle, GKH. Okay. Now, as soon as you separate the two triangles, you have a problem that we've already solved before. Okay, now that they're separate, obviously we can use our similarity statement. So if you notice, obviously K is going to be congruent to K. J is congruent to G. And L is congruent to H. Okay, now the tricky part is filling in the values from the original picture. Okay, so obviously GH is X, that's the value we're solving for, and KG is 6. JL is 15, but here KJ, okay, what you have to notice is that JK, the length of JK is equal to the length of KG plus the length of GJ. So the total length of JK is actually 6 plus 4, which of course is 10. Okay, without adding those two together, you won't get a correct answer. But now your problem looks exactly as it did in the other problems that we solved. Okay, so obviously 10 corresponds to 6 and 15 corresponds to X. We can now cross multiply. So I get 10X is equal to 15 times 6, which is 90. My last step is always to divide by 10, so X equals 9. Okay. Same thing for number 6. Try practice drawing, separating the figures. The good news here is that the length of DA, okay, that is Y. So we don't have to do any adding sides together to get our full length. And then, of course, AE is X. So if you want to stop the video and try redrawing the two triangles and then filling in the numbers, please go right ahead and pause. Okay, so my little triangle is ABC, and then my larger triangle is a DE. Okay, and so on the larger triangle, this is X and this is Y, and those are the two values we have to solve for. But the length of DE is 12.5. Now, for A, B, and C, those are all filled in. All four of those are filled in for me. So the only scale factor that we have to compare the two triangles is 5 to 2.5. I'm sorry, 5 to 12.5, my apologies. So we're going to use that scale factor, 5 to 12.5, to solve for both X and Y, because that's the only known value of my larger triangle. So if we solve for X first, notice that I put the 5 on top, which is backwards from what I previously told you in terms of finding the dilations. But when it comes to solving for a missing side, the proportion doesn't matter because the scale factor is the same. But I listed my 5 on top. So to solve for X, that comes from the larger triangle, and that corresponds with side with the length of 4. So when I cross multiply, I'm going to get 5x equals 12.5 times 4, and that's 50. And when we divide both sides by 5, x equals 10. Okay, and then we're going to use the same exact scale factor. This time we're going to solve for y, and that side that corresponds is 3. So we have 5y is equal to 12.5 times 3, which is 37.5. And our last step is to divide by 5, and I get 7.5. So that is the value of y. And again, you can verify that the scale factor is correct by corresponding the sides. So we know we have 12.5 over 5. I have 10 over 4, and I have 7.5 over 3. Now, yes, I flipped it. I did 12.5 over 5. And when it comes to solving for, I'll say it again, when it comes to solving for side length, it doesn't matter what's on top and what's on the bottom. Okay? The only time it matters is if we're trying to determine whether the dilation of the figure is either an enlargement or a reduction. Okay, that's when it makes the difference. But when it comes to solving for side lengths, I could turn this, I could have reversed these two fractions, and I still would have gotten the same answer because the cross products would have been the same. Now, when I do 12.5 divided by 5, I get 2.5. 10 divided by 4 is 2.5. And 7.5 divided by 3 is 2.5. So this is my scale factor. And since we were told initially that the triangles were similar, the scale factors do match.